For typical aircraft, you'll see one propeller on the nose of an aircraft or two nacelles on the wings of an aircraft. So just very few and not very well integrated in terms of the entire aircraft system. What we're looking at is how highly distributed electric propulsion can change the way aircraft are designed. Electric motors, controllers have just made incredible breakthroughs over the last 10 years. We're able to get 4 horsepower per pound out of an electric motor and controller, which is as good as a turbine engine. And for that same electric motor, that's 95% efficient. Well, if you look at a turbine, that's about 45% efficient. So the idea has been around a long time to distribute the propulsion, but because of the characteristics of reciprocating and turbine engine technologies, we simply couldn't do it in practical, feasible ways. Electric propulsion lets us have this new degree of freedom to put the engines and propulsors anywhere we want without mechanical complexity. It opens up the degrees of freedom that an aircraft designer can use these propulsion technologies. And in terms of the capabilities that can create for us, very low energy consumption, very low emissions. And in fact, the aircraft that we're designing right now and taking to a flight demonstrator can use 5 times less energy than the best general aviation aircraft out on the market today. For this LEAPTech project, we have fantastic industry partners. Joby Aviation and ES Aero, smaller companies that can take higher risk and be much more agile, who are helping us to build the hardware, to test the hardware, to perform very, very rapid analyses and bring it back so that we can put all the different jigsaw puzzle pieces together into a cohesive whole that all the discipline experts say makes sense. We're working kind of in a spiral development where we're working at the small scale with UAVs. We're able to quickly get to flight testing and learn from that experience. So we've been working at that small scale for the past year to 2 years. This year we're at the larger scale where we're building a 31-foot span wing with 300 horsepower and testing that wing. So the third spiral that we're just starting to work on is actually a flight demonstrator at the general aviation size, where we'll be having an X-plane over the next 3 years to prove that all these different disciplines can work together in very, very highly coupled fashion to achieve the objectives that I've been discussing.